All right, we are in section 6.5, where we are going to look at similarity and measurement. So we talked a little bit about similar figures in 6.4, and the main objective that we want to keep in mind when it comes to solving similar figures is once we know that two shapes are similar, we can automatically make two assumptions. One is that the corresponding angles will be the same, corresponding angles will be congruent. The second thing is the corresponding sides will be proportional. Okay, so you're going to be asked to set up proportions with corresponding sides. Usually what you're going to do is you're going to set these up where you'll be using corresponding signs that have given values, given measurements for the sides. And then for the most part, you're going to be asked to find a certain value. Usually it's like a variable x. Sometimes it's other variables, of course, but for the most part, you're going to be asked to solve a certain variable. When you do that, you cross multiply the equation like we did in earlier on in the chapter, distribute if necessary, and then we solve for x. Okay, so right here, what I really want you to do is pay attention to this passage here. It says, given that A, B, C, D, and then this little symbol here means similar. All right, so anytime you see like a wavy line like that, it means similar to E, F, G, H. So this right here is called a similarity statement. So if you have a similarity statement like we have here, we can now make those assumptions. We can now say, oh, the corresponding angles are congruent and the corresponding sides are in fact proportional. Okay, so here is what you should do in order to find these unknown values. So in this case, they want you to find what the side length of EF. All right, EF is right here. Okay, so to set up the proportion, what I usually do is let's look at, so let's call this shape number one, and we'll call this shape number two. Okay, so as long as you are consistent on what you are placing in the numerator and placing in the denominator for what shape it is, you should be okay when it comes to solving for the unknown. So what I want to do is I am going to make sure that all of my values in the numerator come from shape number one, and all of the values in the denominator come from shape number two. Okay, so what I'm going to do here is let's look at, I'm not even going to put numbers in. I'm just going to look at corresponding sides. So it appears to be in shape number one. You are given line segment AB and you are given line segment AD. So those are given values. One AB is 3, AD is 6. All right, so looking at this with shape number one, I can say that AB is going to go on the top over. Now I got to find the corresponding side to AB. All right, how you can find that is I look at, oh, A and B are the first two values there, so that means that EF is the corresponding side. So EF is right here. So I'm going to say, ooh, that's EF. Okay. Now it's going to be equal to, now I know I have a value for AD, and the corresponding side for that will come from the first and fourth digit. So that means that you could say that EH is your corresponding side. All right, so now that we've set up the proportion with corresponding sides, now we get to write in if it has a number, put it in the number. If it has a variable, put in the variable. So in this case, it's going to be 3 over x is going to be equal to 6 over 4. And then we just do cross products here and here. So it comes 6x equals 12. In order to solve for x, I must divide by 6. So then x is going to equal 2, and it was centimeters was our value. All right, so keep moving along. We have some more values here. We have another similarity statement. They're telling us that triangle ABC is similar to triangle DEF. They're asking us to find AB. All right, so same thing. Denote one of the shapes as shape number 1 and the other one as shape number 2. All right, so again, anything that's going to be in the numerator is going to come from shape number 1. Anything in the denominator is going to come from shape number 2. So I look at shape number 1. I have measurement here, and I have a variable here. Okay, so it looks like I have AB as my variable, so I'll write that in over the corresponding side to AB will be DE. First and second in the statement, first and second in the statement. And it's going to be equal to the known value in shape 1 is going to come from BC. All right, second and third, so that means that EF is my corresponding side. So fill in what we need to fill in with the values. AB is a variable x over DE, which is a value of 20. And it's going to be equal to BC, which is 45, over EF, which is 90. Okay, so now we do the cross products. 90 times x is 90x, and 20 times it by 45 is 900. From here, we divide everything by 90, which means x is going to equal 10, and it was labeled as inches. Okay. Going over here, we got uh, ABCD is similar to EFGH. They're asking us to find AB. All right, so we go here. They appear to be rectangles. So one of the things that we can make an assumption on is this is going to be 24 meters and this is 8 meters. Same thing. I can say that this is 15 meters and this is also going to be the variable x. So even though that they may not have given us the size for the corresponding side, but we can figure it out because it represents a rectangle. So I come here and I'm going to call this object 1. I'm going to call this object 2. So again, any side lengths coming from object 1 is going to be in the numerator. Anything with side lengths coming from object 2 will be in the denominator. All right, you can have them flipped. That doesn't change it, but as long as you're consistent with how you're placing it, that's the main goal. So corresponding sides, looks like AB is my variable. The corresponding side to that would be EF, and then it's going to be proportional to the given value, which is BC, and second and third. So FG is going to be the corresponding side. So I look here, AB is right there, that's X. EF, which is right here, that's 8. is going to be proportional to BC right here, which is 15, over FG, which is right here, which is 24. Set up, we set up the proportion, so now we solve it using cross products. 24 times x is 24x, and 8 times it by 15 is 120. Divide both sides by 24. I get x equals 5, and it was labeled as meters. All right, so sometimes we have, it says indirect measurement. It says I can find out how tall a tree is using similar triangles. So if you look here, they were able to measure the shadow of the tree, and they were able to measure the person and the shadow of the person. The only thing we don't know is uh, the height of the tree. So how we set that up is, again, you have to be consistent with what you're placing in the numerator and what you're placing in the denominator. In this case here, you can put shadows in the numerator, so shadow in the numerator, and then anything that's not a shadow in the denominator. Okay, so if you look here, the tree shadow is 11 feet over the non-shadow of the tree. Well, actually, the corresponding would be the shadow of. Actually, nope. Yeah, we can run it like this. The shadow of the human would be what, 5.5. So then we can go over here and say corresponding with the tree would be the non-shadow of it, and the corresponding with the shadow of the human would be 6 feet. Okay, do the cross products. I get 5.5. X is equal to 66. 66 divided by 5.5, which means X is going to equal 12, and it was feet. So the tree's 12 feet. So here is some shapes that are like within shapes. So if you look here, you have a triangle GHJ, which is the smaller one, and they're telling you that it's similar to GKL. So this one here, you will have to do a little bit of algebra in order to find it, but still the same process. Still the same process. So what you could also do is you could certainly break this up into uh, two triangles using the measurements that they have, and then going from there. Or you can keep it in there. You could certainly say like, oh, this one here, this one's G, K, L. We know that it's 21 centimeters here. We know from here to here is 20. We know from here to here is X. So this one's going to be 20 plus X. And then you can go and make it the smaller one, which is HGJ. Say, though, this one's 7 centimeters and this one's X. Okay. You could separate them. You can keep them in with what they have, whatever you feel comfortable with. All right. So just so it separates it, I'm going to say like this is shape. Whoops, my bad. I'm going to say that this is shape number 1 and this is shape number 2. Okay. So same idea in the previous problems when we tied the similarity statement, where I'm going to use everything for shape number 1 on the top, using everything for shape number 2 on the bottom. Okay. So what we have in shape number 1 is I have KL, which is a given value, and KL is second and third, so that means H and J is my corresponding side. And then I go here and looks like I got KG. And I go over here, first and second, so that means first and second, so that's gonna, well, I'll just put it as HG, just to stay consistent with how I wrote it. You could flip them for sure, certainly, but so now I can plug in the values. So I got KL, which is 21. I got HJ, which is 7, and that's going to be proportional to uh, KG, which is 20 plus X over um, HG, which is simply just X. So go over here and we do the cross product. So when we do the cross products here, it's essentially going to be 7 times by the quantity of 20 plus X, and it's going to be equal to 21X. So got to distribute. So when I distribute, I get 7 times 20, which is 140, plus 7 times X, which is 7X, and that equals 21X. So since I got variables on both sides, I just got to get it on 1, so I'm going to subtract 7X to both sides. I got 140 is equal to 14X. Divide everything by 14. I get X equaling 10, and it was centimeters. Okay. Same thing goes here. All right, so I got, this is like my object 1, this is my object 2, same thing. Object 1 over object 2. Given the values here, looks like AB, I have given values over the corresponding side would be AG, and that'll be equal to AD over AE. All right, it's just, I'm just counting and looking at the similarity statement to help me find that. So looking at this, AB is going to be X plus 8, because you go from here to here's X, from here to here's 8, you add them together, over AG, which is just 8, and that's going to be proportional to AD, which is 5 plus 15, which is 20, over uh, AE, which is simply just 5. So do the cross products. I got 5 times by the quantity of X plus 8 is equal to 20 times it by 8. So I must distribute on the left-hand side in this case. I got 5x plus 40, and I have 20 times 8, which is 160. So now we just have an algebraic problem. Got to solve for, subtract 40 to both sides. I get 5x is equal to 120, and then divide everything by 5. X will equal 24, and that will be denoted as meters. Okay. All right, last one. So last one here, it says try this. So I go here, and again, this is like object 1, this is object 2. So I go here and I say, all right, I got A, B over A, G. It's going to be proportional to AD over, well, we'll call this just H. We'll give this in the value, so AH. Sorry, I didn't get to note that as a point. So AB is 14 plus 7, which is 21, over AG, which is just 14. This is going to be equal to AD, which is X plus 18, or 18 plus X, whatever you prefer. And then AH is just 18. So do the cross products. I got 21 times 18, which is 378. And that's going to equal to 14 times by the quantity of x plus 18. So 378 stays the same. 14 times it by x. 14 times it by 18 is 252. Subtract 252 to both sides. So 378 minus 252 is 126. That's going to be equal to 14x. Divide everything by 14. That means x equals 9, and that is meters. And that is being able to look at similarity and measurement. Hope this helps. Until next time.